Hello students, welcome back. We are done with section 1 and let's go to section 2. Sections 2, 3, and 4 are all about graphs. Among these, section 2 is the essential part, the foundation of everything. So it is very important you get comfortable in pretty much everything or almost everything here. Okay, let's begin. The graph of a real function. Here's the definition. The graph of a real function is a set of all points x, y in the coordinate plane where y equals f of x. This is important. Y equals f of x. What do you mean by that? The function value f of x is the y coordinate. Alright? If you're looking for a function value, you have to get the y coordinate. Also, if you calculated function value, you have to put it into y coordinate. That's what this thing is all about. I think I'll have to repeat this maybe 100 times throughout the course. The function value is y coordinate. It's that important. Let's begin with an easy example. Trivially easy. We have this graph, y equals to, or f of x equals to x cubed plus 3x squared minus x minus 2, as good as any, and it is graphed from x is between -4 and +3. And how do we get this graph? Computer selects some millions of x values between -4 and +3 and calculates the function value according to this, all those millions of numbers, and calculates those function values and put those into y coordinates and then plot those x, y. Then you get this kind of curve. Okay, that was simple. And here is even simpler example, simpler concept. If you have a graph of a function, then it follows so-called the vertical line test. What is the essence of the function? Given x value in the domain, only one and only one y value in the range is assigned there. So here we go. We have vertical line, which means everything here on this red line shares the same x coordinate value. Now we have crossing. What do you mean by that? This is part of the graph. So same x value, and right here on this crossing, that y coordinate is the function value. All right? So we have only one y value, which means we have to have only one crossing. If you cross twice, that means you have two function values for x, two y coordinate values for a given x value. That's not a function. This program is randomized, so you can run it again and you're going to get different vertical lines, but each time you have only one crossing. That's easy to see. Okay, we went through an important concept, but examples we saw were very, very easy. And here are even easier examples. Determine whether the given relation is a function or not. Vertical line test. We have two function values here and there for the same x value. So no good. Remember, function value is the y coordinate. We have two crossings. So two function values here and there for the same x coordinate value. No good. This time it's going to be good. We have only one crossing for each x. For each x, we have this one y coordinate value. That y coordinate value is the function value. So each x has only one function value, so that function is well defined. Not coincidentally, y is given as a function expression, x squared. F of x is in this case x squared. Remember, function value is y coordinate. Okay, so much for all the easy examples. Now let's go to some non-trivial example. Here's a graph of a function, y equals to f of x, and let me emphasize yet again, y equals to f of x. What does it mean? The function value f of x is equal to y coordinate. Alright? If you're calculating function value, you're looking for y coordinate. If you are given a function value, that means y coordinate is given. Alright? Function value f of x is y coordinate. Okay, let's begin. Determine the quantity f of 4 minus f of 2 times f of 6. If you find what is f4 and what is f2, and what is f of 6, then we are through. Calculate all these and then put those in here and then calculate, and that's about it. Now, how do we find f of 4 from this equation? That is the key here. Alright, remember, function value is y-coordinate, so you're looking for y-coordinate. X value is 4, x coordinate is 4, so alright, where is x? X value is 0, 1, 2, 3, 4, right here where my mouse is. And then let's move vertically because vertical line shares the same x coordinate. And then go to the point on the graph, right here. This is not it, this is expunged. So right here, function value is y-coordinate, so give me the y-coordinate. Y-coordinate is f of 4. What is it? Is everybody comfortable? Let's do this again. What is f of 2? Again, function value is y-coordinate, so you have to read me the y-coordinate. X-coordinate value is 2, so alright, x is 2, and let's move vertically because vertical line shares the same x-coordinate. So let's move vertically to the point on the graph right here and give me the function value f of 2. F of 2 is which coordinate? Is the y-coordinate. Give me the y-coordinate. What is it? One more exercise. F of 6. Again, we are looking for the function value at x is equal to 6. So the function value is y-coordinate, so you are looking for the y-coordinate. Alright, x equals to 6. Where is it? 1, 2, 3, 4, 5, 6 here. And then, how do I move? I have to move vertically because vertical line shares the same x-coordinate. Alright, I got to the point on the graph. What's the answer? What's f of 6? Which coordinate do I have to read? It's the y-coordinate of this point, and that is 3. Let's go to the answer key here. 1, 5, and 3 respectively. And here I gave you some illustration with some color coding. Start from x equal to 4 from the x-axis and move vertically to the point on the graph, and that point has y-coordinate 1. That's a red point. And then start from x equals to 2 on the x-axis and move vertically to the point on the graph. We got to that point, and what's your function value? That's the y-coordinate, so we have y equals to 5. Same thing goes here to this green point. Start from x equal to 6 from the x-axis. Move vertically because vertical lines share the same x-coordinate. Go to the point on the graph, and which coordinate do I have to read? Y-coordinate. Why? Because function value is y-coordinate. So y equals to f of x is written here for a reason. Function value, f of x, is y-coordinate. And then calculating this, that's easy. Okay, so much for the forward problems, and let's consider backward problems now. Solve the equation f of x is equal to 3, or equivalently speaking, find all values such that f of x is equal to 3. They all mean the same thing. Sometimes I'm going to write like this, sometimes I'm going to write like that, or maybe even some other expression. In any case, the key is f of x is equal to 3. Now, what do you mean by that? F of x, what is f of x? What is equal to f of x? F of x is which coordinate? F of x is y-coordinate. So basically, this problem is asking you to get this. Y is equal to 3. What is it? What is y equals to 3? What is y equals to 3? y equal to 3 is this horizontal line. X equals to something, that's vertical line. Y equals to something is a horizontal line. Y equal to 3 is here, this vertical line. And where are the points on the graph associated to y equal to 3? I see 2 such points. Wait a minute, 2? Why not 3? No, this point here is expunged and moved down here. So no, this is not part of the graph. So this is not it. There are 2 crossing points, right here and there. Do you see? There are 2 crossing points. Those are 2 points on the graph with y equal to 3. Why am I looking for y equal to 3? Because function value f of x is actually the y coordinate. So y coordinate is equal to 3. I cannot even count how many times I said function value is y coordinate. I cannot count. I already lost track. Maybe I will really indeed reach 100 times. Okay. What are the x-coordinate values for y equal to 3? Right here and right there. Did you get those? They are x equal to 0 and x equal to 6. You see a horizontal line, y equal to 3, and we get these 2 points. Move down 0, move down 6, or even without really moving down, you can read their x-coordinate here and there. Okay, all right. Final problem here. Solve the inequality f of x is less than or equal to 3. In other words, find all x values so that f of x is less than or equal to 3. Previously, we had an equation, f of x is equal to 3. If we have an equation, then the solution set will be some numbers. Maybe one number, x equal to something, or in the previous case, we had 2 numbers, maybe 3 numbers. We'll have some numbers. But if you have inequality, the answer will be an interval, or maybe 2 intervals, maybe 3 intervals. Okay? Equation typically have a solution as a number, or some numbers. Inequalities typically have solution as intervals. An interval or intervals in plural. Well, that was algebra, and how does that apply in this graph problem? Let me give you a hint. I think I'll have to stop the playback here and do some adjusting here. So, okay, I'll stop and then do some coding and then I'll come back. See you soon. All right, welcome back, students. I did my coding and then here's a hint. Now, y coordinate is less than or equal to 3. That part is highlighted in this case by the shading. And then this thick blue part of the graph matters. And those gray parts above y equal to 3, they don't matter. So look at only the blue part and tell me which x coordinates will give me those blue parts. What do you think? Did you get it? Maybe some further hint? In order to give you some further hint, I'll have to stop the playback again. Okay, let's stop the recording and I'll do some more coding here. Okay, all right. Okay, all right. Here's further hint. So in this x value, you get this blue part. Other x values, no, we don't. In this x value, we get this blue part. Otherwise, no. So what is the solution? I hope you see 2 intervals. Here's the answer. -1 to 0 or 4 to 6. So we have this solution set. Okay, the final problem was a little bit hard, but otherwise they're all essential problems and everybody should be comfortable with those.